All right, today we are going to learn about writing and applying exponential and power functions. So an exponential function is something that has an x in the exponent, and a power function is going to have an exponent, but the x is not in the exponent. So we will be able to write a power function whose graph passes through two given points, and also an exponential function, and then use exponential and power regression. So our first one, we're going to write an exponential function in the form y equals ab to the x, whose graph passes through 112 and 108. So just like we've done this in the past, we need to find the a and b value. And so we're going to have a system of equations. Since we have 2 points and we have 2 unknowns, we're going to have 2 equations. So the points are x and y. So here's x and y, here's an x and a y. So we're going to have 2 different equations. So we have 12 equals a times b to the x, which is 1. And then we also have 108 equals a times b to the third. Now, the only way we can solve this is by using substitution, because we cannot use linear combination because it is not a linear function. So you can solve for a or b in either function. It is easier to solve for a in general. And since this first one has an exponent of b to the first, that one looks to be the easiest to solve for a. Now you could also solve for a in the second one as well. Okay. So the first one, I'm going to solve for a. So we get 12 equals a times b. So I've got to divide by b. So I have a is equal to 12 over b. Now I'm going to substitute this into this equation for a. So I'm going to have 108 equals 12 over b times b to the third. Okay, we don't really need this times there. We can extend the line, and it's 12b to the third over b. And let's simplify that. We use our exponent rules, and we can subtract our exponents. 3 minus 1 is 2, so we have 12b squared on the top. Now we're solving for b, so go ahead and divide by 12. So b squared is 9. And then we take the square root. When you take the square root, again, you have plus or minus 3. But we want to use b equals 3 because we want b to be greater than 0. Remember, the base of our exponential is always greater than 0. So we're not actually going to use the negative 3. We'll use b equals 3 as our b value. It has to be positive. B is greater than 0. Okay, so now we need to find a, so we plug that back into any equation that has an a and a b. I'm going to plug it in there, so a is equal to 12 over 3, which is 4, so a is 4. Then my exponential function is y equals 4 times 3 to the x, and this is my final answer. Now, it would have worked the same way if you had solved for a in the second equation. You would have just had something different to substitute in, and a little bit different of a process, but same idea. So I would just always solve for a, because that will be easier to solve for in general. All right. Now we're going to use the graphing calculator to find an exponential model for the data in this example. Predict the number of scooters sold in the 8th year. So this is just like all of the other regression that we have done. You're going to plug it into your calculator, So remember, you're entering your data into your list 1 and list 2, and that's in stat edit. Okay, so we're going to go there now. So in our calculator, we're going to go to stat and then edit. And I have already put them in this list. So if you need to clear out your list, go up to the list and hit clear and then enter, and then put in all of your X's and all of your Y's. Then you're going to hit second quit. And then remember, we use stat, and then we'll go to calc. And then this time we're going to do exponential regression. Okay, because that's what we were looking for, an exponential model. So stat, calc, and then exponential, you're going to have to arrow down a little ways. Exponential is 0. So then you're going to hit enter, 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 calculate. So we got our model, a, b to the x, and we'll do 3 decimal places as usual. So we have y equals a, so 8.457 times, we'll put a parenthesis there, 1.419 to the x. So this is our model. Okay, so just like before with all of our quadratic and polynomial regression. Then it wants us to find the number of, scooters sold in the 8th year. So year is x, so that means we're plugging in 8 for x. So x is equal to 8. So when we plug in 8 in there, we're going to get about 139 scooters sold. And that's rounded because you can't have part of a scooter. Okay. Now we're going to move on to power functions. So we're going to write a power function, and that's in the form y equals a x to the b, whose graph passes through the 2 points. So now we have a b in the exponent, so this could be a polynomial, but we don't have any other things added onto it. So this is the power function, just x to a power, okay? So again, same thing, we're going to plug in our values in for x and y. So we're going to have 2 equations. 2 equals a times 3 to the b, and 9 equals a times 6 to the b. So those are our 2 equations. Now again, we need to solve for one of the variables, a or b. Well, which one looks to be easier to solve for right away? And to me, it looks like a is easier. So the first thing I'm going to do is solve for a. Okay, and I'm going to, it doesn't matter which one you use, they both look equally as easy, so I'm going to pick the first one and I'm going to solve for a. So I have 2 equals a times 3 to the b. To get rid of 3 to the b, I'm going to divide. So I have a is equal to 2 over 3 to the b. Now, it's my substitution step, so we substitute. So this part goes in for a in the other equation. So we get 9 equals 2 over 3 to the b times 6 to the b. And that's just over that same fraction. Okay, using our rules with exponents, these have the same exponent. 6 to the b over 3 to the b, we can kind of group them together. So we have 2 times 6 to the b over 3 to the b. I have changed nothing. I've just grouped it differently. And we can use our rule of exponents and take out the b. So I have 9 equals 2 times 6 over 3 to the b. And so then this gives me 9 equals 2 times 2 to the b. Okay, so I just use my rule of exponent. They have the same exponent, so I can take it out and divide those numbers. Now I'm still solving for b, so this is where our logarithms are going to come up. We need to divide by 2 first. And so you can leave that as a fraction, or you can change it to a decimal. That's 4.5 equals 2 to the b. Then this is the time when we take the log of both sides. So we're going to take log of 4.5 equals log of 2 to the b. Then this exponent comes out front, so we have log of 4.5 equals b times log of 2, and then we divide by log 2. So we have b equals, so now we take log of 4.5 over log of 2, and we get about 2.17. I think that's what that rounds to. If I'm wrong with that, round it to 3 decimal places, but I think that's what it was. So that's our b value. Now you're going to substitute that back in for either one for a. So I'm going to use this one right here. I'm substituting it in. I have 2 over 3 to the 2.17, and that's going to give me a. And when you put that in your calculator, a ends up being 0.184. So then my power function is y equals 0.184 x to the 2.17. So if you remember when we did polynomials, it was always to integer power, but a power function doesn't have to be to an integer power or a whole number power. So that's why it's different. So we have a number in the exponent, and this is a power function for those two equations, or 2 points. Okay, so now we're going to do the same thing with the calculator, but with power regression. So use the graphing calculator to find the power model for the data, estimate the weight of a bird with a wingspan of 4.5 feet. So here's our table. X is our wingspan, Y is the weight. So you're going to go back to your calculator and do your stat edit again. And I'm going to clear these lists out. So clear, enter, go over here, clear, enter, and then I'm going to enter in that data. So X, we have 1.9, 2.92, 3.41, 5.35, and 8.40. And for the Y's, we have 0.23, 1.04, 1.69, 6.76, and 16.03. Okay, so that's our two lists. And then you're going to hit second quit and go to stat calc again. And this time you're looking for power regression, and so that's the letter A, so power regression. That's what you're looking for. And then same thing as always, enter, 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 calculate that. And we're going to do, again, 3 decimal places. And if we have any place setting zeros, in this case we do have one, we'll go 3 after any place setting zeros. So we get y equals A, so 0.0442, x to the power of 2.17, 2.872. Around 2.872. Okay. And get out of that. So that's our model. I kind of went over onto the table, but you get the point. And we needed to figure out the wingspan, so estimate the weight of a bird with the wingspan of 4.5. So sorry, we need to find the weight. So x is the wingspan. So 4.5 is plugging in for x here. And so estimating the weight of the bird, we should get about 3.32 pounds, something close to that. So that's the weight of the bird. Okay, and that is all there is. So your homework is on your homework sheet, and the rest of the time you should be working on that homework. Again, remember I am here after school, so if you have any other additional questions, make sure you come in and ask me.